Welcome to the lesson on trigonometric functions. The objective of these lessons will be to identify the 6 trigonometric functions, to express trigonometric ratios as reciprocals of each other, and finally to determine all trigonometric ratios from a given angled triangle. We will be applying our past knowledge of right angled triangles to new situations, and we will be thinking interdependently. Some of the key terms we'll be using in this lesson include trigonometric functions and ratios, reciprocal functions, and inverse functions. We're going to look at the first 3 trigonometric ratios. Of course, if we have a right angled triangle with a given angle, we should be able to identify the hypotenuse, which is usually the side opposite the right angle, the opposite side, which is the side opposite the side that is given, and the third angle being the adjacent angle. The sine of the given angle is usually the opposite side divided by the hypotenuse side, while the cosine of the angle is the adjacent side over the hypotenuse side, and the tangent of the angle is the opposite side over the adjacent side. So ka toi. We should remember this because it's key for us to remember the formula of the trigonometric ratio, both the first 3 ratios and the ratios. Now the next 3 trigonometric ratios are reciprocals of the first 3 ratios. We have the cosecant theta, which is the hypotenuse over the opposite side, the secant theta, which is the hypotenuse over the adjacent side, and the cotangent theta, which is the adjacent side over the hypotenuse side. The cotangent theta is adjacent side over this side. Now, if you see sine theta is opposite over hypotenuse. It is the reciprocal of the cosecant, while the cosecant is hypotenuse over the opposite. It is the reciprocal of the sine. We have the cos theta, which is the reciprocal of the secant. The secant is the reciprocal of the cosine. The tangent is the reciprocal of the cotangent, and the cotangent is reciprocal of the tangent. Now, given a triangle with the opposite side as 5 cm and the adjacent side as 12 cm, we are asked to find all the length of the 6 trigonometric ratios. The first aspect is to use Pythagoras theorem to find the hypotenuse, and we know that the square of the hypotenuse is equal to the sum of the square of the other 2 sides. Therefore, hypotenuse square will be 25 squared plus 144, which gives us 169. The square root of 169 is 13. Now we know that the hypotenuse is 13. So our sine will be the opposite over the hypotenuse, which is 5 over 13, while the cosecant will be opposite over hypotenuse, 13 over 5. The cosine is adjacent over hypotenuse, 12 over 13, and the secant, which is the inverse, the reciprocal of the cosine, will be 13 over 12. Our tangent is opposite over adjacent, which is 5 over 12, and the cotangent, which is the reciprocal, is 12 over 5. Thanks for watching. You can get better only by practicing more exercises. For more activities on trigonometric ratio, visit the link below.